So if we are asked to determine something like this, and we are given a table for x and f of x, and of course a table for x and g of x. What would I have to determine first?
G of 3?
Right. So let's say this is 5. I read it from the table, and I read it's 5. So then I get f of 5, and I read from the table of f, and I get whatever 10. Be careful how you read from the table, right? Any questions on that?
No.
Okay, so if I'm given a function f of x, let's say 2x minus 1, and a function g of x, let's say 2x squared minus 4. Do I know how to determine f comma g and g comma f, and let's say also g comma f at 0? Any questions on this? Is this okay?
I think at lab core.
Okay, so I'm assuming you have no difficulties with this. So if I'm given a function like f of x equals x squared minus 3x plus 2, and I'm asked to graph it. Any questions? Any doubts about the axis of symmetry, domain, finding the vertex, x-intercept, y-intercept? Any questions on this? Okay.
Can you do that one?
So we have to find the shape, and the shape is a minimum because a is 1. In number 2, we find the vertex, negative b over 2a, b, negative 3 over 2 times a, so it's 3/2. And then I have to find the function value at 3/2. So f of 3 over 2 is 9 over 4, minus 9 over 2 and plus 2. Find the least common denominator. So this needs a 2 and this needs a 4. So 9 minus 18 and plus 8. And that's negative 1/4. We know this, we've done that several times, but just to refresh our memory. In step number 3, I need the x-intercepts. Do they exist? Yes, because the minimum value is negative 1/4. I already know the range. It has a minimum, and the minimum value is negative 1/4, so the range is negative 1/4 to infinity. So the x-intercepts exist, so I determine x-intercepts when y is 0, and that is x squared minus 3x plus 2 equals 0, or x minus 1, x minus 2. And we get two options, 1 and 2. So we have a point 1 comma 0 and a point 2 comma 0. And then 4 is the y-intercept when x is 0, 2. So 0 comma 2. And then the axis of symmetry, x equals 3/2 is the axis of symmetry. And then 6, because I already have 7 here, I already wrote the range. And 6 is the minimum. Min is negative 1/4. So all I have to do is just put everything together. So 3/2 is 1.5, so that would be the axis of symmetry. And then I have 1 comma 2, 1 comma 0 and 2 comma 0, and I have 0 comma 2. And the vertex is at negative 0.25. So that's the function f of x, x squared minus 3x plus 2. Any questions on this? Please go back and redo the problems we did in class so you're very confident. You don't have to go back and forth to anything. Now, what about the domain of this function? The square of x plus 4 over x plus 3. Do we know how to determine the domain of this function?
Is it -3 to infinity?
So, first of all, I have to write that x plus 4 has to be greater than to 0. And then I have to write that x cannot equal -3, because x plus 3 cannot be 0. So this one means greater than or equal to -4. On the real line, -4 to infinity. But I'm not allowed to pick -3. Not -3. So the domain of this function is -4, -3 union, -3 infinity. There are two conditions for this function. Any questions on transformations? Any questions on inverse functions? If I'm asked, for example, to find f of, I'm given f of x, let's say I'm asked to find 2 times f of x. What transformation is this of the function f of x?
Can you repeat that question?
So I'm given function f of x. So let's say this is the function. This is function f of x. And I'm asked to explain how to graph twice f of x. That is a
Horizontal stretch?
vertical stretching by a factor of 2, because it's outside, it doesn't touch x. If it were 2 in here, it would have been a horizontal shrinking, but it's 2 outside of y. So all these heights get doubled. This height gets doubled. Vertical stretching by a factor of 2. Now, we did not talk about synthetic division, so there is no need to use synthetic division. So when you get to a division, blah 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 over blah blah blah, use long division and write the answer, not synthetic division. We haven't talked about it. So do not use synthetic division, use long division. How to find the inverse function? If I have f of x equals 2x minus 3, how do I find the inverse function? And how do I graph that?
Replace the x with y?
Yes. Now, first, this is y equals 2x minus 3. Then I have x equals 2y minus 3. I add 3 and divide by 2. So this is f inverse. How do I graph both on the same coordinate system? What do I have to graph? For sure, when I graph the function and its inverse.
Y equals x?
Yes. So you will find 2 points for this, and then you will reverse them for that. Let me know if that's okay. Well, you have in my math lab, you have the options, but you should still graph them so you don't make an error, because there is no partial credit here. Graphing of a rational function. We looked at a lot of them, but if you want to review graphing a rational function. Circle. Okay, no one says anything. F come G of 1. This equals F of G of 1. If I'm given graphs, I will determine this first. Read it from the graph. Let's say it's 3. And then I would have to read F of 3, let's say is 10. Exactly what we did with the table. But we can be given a graph. Increasing, decreasing. Do we know how to write the intervals of increasing, decreasing for a function? What is the end behavior of a polynomial function? Odd degree. Two possibilities. Yes, go ahead. So odd degree with a leading coefficient that is positive will be from negative infinity to infinity. With a negative leading coefficient will be from positive infinity to negative infinity. For an even degree, for A, which is positive, the leading coefficient is positive, infinity to infinity. For the leading coefficient which is negative, from negative infinity back to negative infinity. We know multiplicities and what they mean. Okay. We talked about the slant asymptote. We're not asked to graph. Do we know how to find the slant asymptote? It's the same problem with the long division problem. Anything? Word problems with quadratic functions. The ball that is thrown, so it starts here, goes to a maximum, and it hits the ground. We've done like 2 or 3 problems like that one. Any questions? The last problem will be extra credit. Just keep that in mind. Last problem, which will be 19. Number 19 is the extra credit. So basically you have 18 questions. And the last one is extra credit. Okay? Any questions for me?
No.
Okay, so let's, in that case, if you don't have questions, I'm still available for you before the test. If you have anything for me, let me know. So I would like to go back to chapter 4 then. And remember we talked about the exponential function, and we're going to talk about you won't let me get out of this pre-test. Okay, so I started the pre-test, and now it's not allowing me to get out of that. I don't understand why. Okay, never mind, I'll deal with that later. Okay, so let's continue with section 4.2. Logarithmic. Functions. Okay, let me refresh your memory about the exponential function, because they are very well connected, these two functions. So when we graph the exponential function with a base greater than 1, we graphed this. And we graphed specifically 2 to the x. Then we graphed this, which was 1/2 to the x. After that we said, okay, the functions are both 1 to 1. They have inverse functions. And we immediately graphed the inverse functions. And here's how we graphed the first one, reversing the ordered pairs. And we got this. And remember, when the function crosses y equals x at a point, at the same point, the inverse function will cross y equals x. The exact same point. So then this is the inverse function of this function, and this is the inverse function of 1/2 to the x. If the function is increasing, so is its inverse. If the function is decreasing, so is its inverse. So this is what we call log function. This, the notation, I know it looks fancy, it's really nothing. But this is the notation log. It has to be the same base. I'll explain how this works in a minute, of x. Now here's the base is 1/2. So this function will be log base 1/2 of x. So let me write it how we read it. Log base 2 of x. Log base 1.
Can you even zoom out just a hair?
From here?
Yeah, just so we can see the top.
Let me see if I can see what you see, so then. Yeah, it's not very clear, I see. So if I move the camera a little bit, move it up. Is this better?
Yes.
It's not my best camera. I'm using my best camera to record. That's why. This is not my best. But as long as you can still see, I have to use this one because it won't allow me to record and at the same time for you to watch. Any questions? that okay? Better? Okay. So here's the next topic, which is I would consider the most important topic in the entire chapter 4. Once we understand this and we know how to apply it, I'm going to write it in a minute, then we should have no difficulties with this chapter, I think. So first, in plain English, any logarithmic equation can be replaced by an exponential equation, comma, and vice versa. Any log equation can be replaced by an exponential, and any exponential can be replaced by a log equation. And you can say, what's the big deal? And you will see why. We're going to use this all the time. Now, in mathematical terms, how do I explain this? How do I express this? So we know how to express a log function now. Log in any base A of x is just a number. This is a log equation. It has a left-hand side, it has the equal symbol, and it has the right-hand side. Log base A of x is y. And now here comes the double equivalency symbol. This equation can be turned into this equation can be turned into this equation. And here's how we convert it. We start with the base, and we go counterclockwise. A power, this is a power now. A raised to y equals x. I claim that this is the most important topic in this chapter.